All right, here's some great questions regarding linear functions. So they say write a slope-intercept equation for a line with those characteristics. So I have a slope of this and that. So I know I need to get something of this form. So I need to find a slope and a y-intercept. They gave me the slope, so I can just sort of plug that in right there. But they also gave me a point, an x and a y value. So I can plug those in right there and there. Make sure you put the right one in the right spot. So negative 4 equals negative 2/5 times negative 3 plus b. So now all I have to do is solve this equation for b. So negative 4 equals, this would be positive 6/5 plus b. And then I'll subtract 6/5 on each side. So get b is equal to, I don't know what that is, negative 5 1/5, negative 26/5. Check that on the calculator. I think that's right. Anyway, so now I have my b value. Now to write my equation, it's supposed to look like this. And all I need is a slope and a y-intercept. They gave me a slope in the first place, and I just found the y-intercept. So I just plug those things in. Negative 2/5 for the slope, and the y-intercept, negative 26/5. So that would be my y-intercept equation that satisfies the slope and that point. Okay, here's a couple other questions where they say use a graphing calculator. So we use Desmos, and we'll plug in this data, and then we'll do some estimating there. Okay, so let me fire up Desmos. I'm just going to move it down a bit, right about to there. Okay. All right, so I want to put that data in Desmos. So in Desmos, you hit the plus sign, hit a table, and then type this stuff in. So 50, 166. 60 is 169. 70 is 172. 70, 72, and 80 is 175. When you look at the numbers, they're all going up. The x values are going up by 10, and the y values are going up by 3. So you know it's a linear functions because there's a consistent increase. Now I can't see my points, so an easy way to see where those points are is you hit that tool button up there, and then in here you can type your x-axis. So my x's go from 50 to 80. I usually try and put some a little bit before and a little bit after that. So I'll maybe try and go, my x's, I'll maybe type 40 for that, and the high will maybe go 90. Okay, is that 90? Oh, 90. And then my y values, they start at 166, go to 175. Maybe I'll start at 150 and go to 190. There. So now you can see those 4 points. Now what I want to do is I want to tell Desmos to use regression. Where do they say that? Somewhere in there. Or to model the data. So to tell Desmos you want to model this data, you type out a function, and I think this is linear, so we'll use a linear function. And this is the way you do it. So it's y1, and then you put a tilde, that's that little wavy looking guy, and then mx plus b. Oh, I forgot. The x needs to have a 1 on it. mx1 plus b. Where's a b? There. Okay. So down below there, it shows me, yeah, you can see it right there. So it shows you what the slope is and what the y-intercept is. So I can write an equation for it. So, what, not m, y is equal to mx plus b. So y is equal to, the m value is 0.3, so 0.3. And they say round to the nearest tenth, so that's good. X plus the y-intercept is 151. So they'll ask you those questions. They'll say, what's the slope, what's the y-intercept? And then they'll say, estimate the heart rate if you have a resting heart, or estimate the maximum heart rate if your resting heart's 43. So then what you can do is on a calculator, plug in the 43 wherever there's an X. So put a 43 there, and then figure this out. And that'll tell you what the maximum heart rate is if your resting heart rate is 43. Another way to do that same thing is if you go into decimals again, and down below here, type the equation x equals, and whatever that number is, 43. 43, there. And so you see in decimals where the red line, that's 43, intersects my or decimals' line. If I tap where they intersect, that tells me what the maximum heart rate will be for a person that has 43 as their resting heart rate. I wonder if that's the same. Oh, no, it'll be right, because it'll be a little bit less than 166. Yeah, so 163.9, that's about right. And then they ask you for what it is for 63 and 75, so you could just take that number and change it to a 63 and see where it crosses. So it'd be 169.9, and you could keep doing that. Or, like I say, plug them in. Another thing that you can do is it says, what is the correlation coefficient? And a correlation coefficient just means this line that they come up with, the y-intercept and the b, so this line right there, they're saying how accurate is that? And it gives you accuracy on a scale from 0 to 1. So the closer you are to 1, the more it represents the data exactly. So if you look at our R value right here, that one, our correlation coefficient, that's what R is 1. That means that this line that they gave me the slope and the y-intercept for is exactly matched to the data. Let's try another one. And if you want, maybe pause the video and try doing this in decimals, and then come back and see if you're on the right track. Okay, I'll put my numbers in. I hit a plus, make a table. So 0 and 293 and 1. Notice I'm just using the the X value. I don't need to type in the year. It would work too, but it's easier just to say, if you're starting, let's start at 0. Okay, 2, 346, 3 is 359, 4, 382, and 5 is 401, 401. There we go. So I have my data in, and now down below here, I'm going to enter that equation. Now, if you haven't cleared this one, mine's cleared, but if you haven't cleared your table already, you may want to clear it. Otherwise, it'll give you an x2 and a y2, or an x3 and a y3, which you could use, but it's easier just to always use the same one. So, okay, so it's y1 tilde, and that sort of stands for equal sign, or it's telling you to look at the data and get a relationship. Okay, x1 plus b. There we go. Okay, so there I have my slope and my y-intercept. This one they tell you to round it to the nearest hundredth. Oh, and I can't see the data here yet. Why don't I change my thing here? So my x's go from 0 to 5. I'm going to take it and go like -2 to 10. That sounds good. Y value is 293 to 401. So why don't I start it maybe at 250 and go up to, say, 450. There we go. Okay. So there, notice on this one, the line is an average of the data. So it doesn't go through all the data, but it's sort of an average line. And that's what you're trying to do, is model the data as close as you can. Notice the correlation coefficient for this one isn't exactly 1. It's close, 0.9619. Oh, no, sorry, it's not that one, it's this one. 0.9807, so it's close, but it's not bang on to 1. Okay, so let's write our equation. It has to look like this. And decimals tells you what your slope is. 19. Now they say round to the nearest hundredth. So let's go 19.83. 19.83x plus the y-intercept 303.10, I think. 303.10. Okay, again, then they say predict what it'll cost them in 2020. So I need to figure out what number here corresponds with 2020. So if I go 15, that'll be 6, 16 will be 7, 17 will be 8, 19 will be 9, 2020 will be 10. Oh, that's what they want. So if you want, you can plug a 10 in right there. So 19.83 times 10 plus 303.10, and figure out what that comes out to, and that'll tell you what the average monthly cost should be in 2020. Another way to do that, like I said on the other video, is in here. Whoops. Oh, right there, is type out that value. So x equals 10. So I put a 10 in. Uh-oh, I can't see my 10. Oh, there it is. And just tap where they cross. So at 10, we would assume that the average monthly cost to workers for family health insurance will be about $501. Okay, last question. Find the slope and y-intercept of the graph of the linear equation, then write the equation. So I need to write y equals mx plus b. So when you look at the graph, you might be able to tell the slope right off, but I always find the y-intercept first. So it looks like the y-intercept is right there. And I think that's at -1. So this b value is -1. Now I just have to figure out the slope. So to get the slope, you want to go from any point on the line to another point that you know for sure is 1. I think right there is a point that's right on. So if I look at my slope, it'll be up 1, 2, 3, 4, and then 1 to the right. So my slope is rise over run. And you could also do that y2 minus y1 over x2 minus x1. You can do that with those points. So the point is 0 and -1 is 1 point, and the other point is 1 and 3, I think. So you can use these as an x1, y1, x2, y2, and plug into this formula. Or just look at it. I go up 4 and over 1, so my slope is 4 over 1, or just 4. So that would be the equation of the line that's in red there. Okay, hopefully that helps you with those 4 questions.